you already know many abbreviations and acronyms. Understanding the relevant ones is essential, whether you need to read technical literature, produce your own research, develop products, or promote your research ideas or products to potential sponsors and customers. In a few seconds, we will take a very brief look at 3 sets of categories that describe various aspects of a technology's maturity. You will encounter these in a wide variety of industry and academic settings, especially if you hope to promote technologies, products, or research ideas to government organizations such as the U.S. Department of Defense, NASA, or ESA. Don't worry, there are abbreviations, but it isn't all alphabet soup, and we'll connect you with resources for learning more if you're looking for more detail. If you find this video or any of our others are useful, or if you have comments or suggestions for us or for other viewers, please comment, like the video, and subscribe to the channel. We'll be right back.
Please see the video description for a full list of disclaimers, including the ones here, plus a timeline and helpful resources and links. Please support the channel by using our affiliate links.
First, we'll look at technology readiness levels, or TRLs. These describe the maturity of a technology. Once some basic research has been done and results are available, the technology has reached TRL 1, where basic principles have been observed and reported. The levels increase from there through TRL 2, formulation of a speculative application or invention, and then analysis to see if it will be feasible. TRL 3, analytical and experimental critical functions and or characteristics are proved or demonstrated. This is the beginning of R&D. It may only involve one component of a planned system, and it could involve some combination of analysis and or experiment. TRL 4 involves component and or breadboard validation in a laboratory, and this may involve some low fidelity integration where multiple components are connected together but not in the most realistic way. Realism increases as we get to TRL 5, where a demonstration is done in a relevant environment, but the relevant environment is more realistic and higher fidelity. TRL 6 involves a system or subsystem model or prototype demonstration in a relevant environment. So at this point, the environment is more realistic than simply a laboratory, and the system under test is also more realistic in that it is a representative model that would have the functions of the planned final product, or it could even be a prototype that looks very similar to the end product. Next is TRL 7, system prototype demonstration in an operational environment, and at this point, that prototype is fully or nearly fully operational and will have nearly or perhaps all of the features of the final product. At TRL 8, development is ended. We have an actual system that's completed and qualified through test and demonstration. So at this point, we're no longer in R&D. This is test and evaluation. At TRL 9, the actual system has been proven either through test and evaluation in operational conditions or through actual use in operation. You'll notice that both the functionality and the durability of the technology increase as we proceed through this list of TRLs. However, in many cases, it is necessary to mass produce a product based on a technology that has been characterized by these TRLs. For that purpose, we have another list of levels known as MRLs, or manufacturing readiness levels. Although these are somewhat correlated with technology readiness levels, there is no one-to-one correspondence, and manufacturability may lag technology development. Here are some resources for learning more about TRLs. Now that we've discussed technology readiness levels, we'll take a look at manufacturing readiness levels, or MRLs. MRLs are used to increase understanding of manufacturing maturity and identify and manage manufacturing risks. These are less relevant for academic research, but are very important as R&D progresses into product development, manufacturing, and marketing. They were developed by the Defense Department in the United States for acquisition purposes to describe manufacturing capability for a particular technology or product. And MRLs are described as a nonlinear ordinal scale that identifies what the manufacturing maturity should be as a function of where a program is in the acquisition life cycle. So, for example, a Defense Department program might seek to develop a technology into a usable system, and specific levels of manufacturability may be expected at various points in the program. There are a couple of really useful resources for MRLs, and one is the Manufacturing Readiness Levels website that's maintained by a collaborative group of industry, academia, and DoD, and provides updated references and tools which comprise what they call the MRL body of knowledge. Among these references or resources is the most recent MRL desk book published in October 2022. From that guidebook, we've taken a table that summarizes the MRLs. The guidebook contains much more information, and I encourage you to look at it if you have an interest in MRLs or need to understand them better. The MRLs range from level 1 to 10, where at MRL 1, basic manufacturing implications have been identified. At MRL 2, manufacturing concepts are identified. At MRL 3, manufacturing proof of concept has been developed. And level 4 represents the capability to produce the technology prototype in a laboratory environment. At level 5, prototype components can be produced in a production relevant environment. At level 6, an entire prototype system or subsystem can be produced in a production relevant environment. At level 7, systems, subsystems, or components can be produced in a production representative environment, which is closer to an actual factory setting or typical manufacturing environment. At level 8, a pilot line capability has been demonstrated. And at level 9, LRIP or LRIP is demonstrated with the capability in place to begin FRP. At level 10, FRP is demonstrated and lean production practices are in place. LRIP is low rate initial production. FRP is full rate production. And MRL 9 comes into play once a decision is made to begin low rate initial production. And the focus at this point is on meeting quality, throughput, and rate of manufacturing to enable transition to full rate production. In MRL 10, the system is in production, and lean practices and continuous improvement approaches are measured. Here's a 2017 article from a company website that identified an entire series or ecosystem of readiness level indicators. In various ways, these could be useful for systems engineering, especially for very complex systems. However, as these systems proliferated, the authors indicated that diminishing returns were achieved. Nonetheless, some of them could be very useful, and these include not only TRLs and MRLs, but interface readiness levels, system readiness levels, and people readiness levels. The authors used this graphic from another publication that shows a rough alignment of TRLs and MRLs. Now that we've discussed TRLs, MRLs, and mentioned some other readiness levels, we'll move on to the last part of the video today, and this one does not include abbreviations as much as numbers. The last system that we will consider here is the set of DoD Research, Development, Test, and Evaluation, or RDT&E Budget Activity Codes. Yes, there are still more abbreviations, but now we also have some numeric codes to remember. According to the Congressional Research Service Defense Primer on RDT&E that included this table, DoD refers to funding in codes 6.1, which is basic research, 6.2, applied research, and 6.3, advanced technology development, as the science and technology, or S&T budget. Particularly through budget activity 6.1, DoD is a major source of support for university R&D in many fields of engineering and in computer and information science. Codes 6.4, 5, and 7 are for near-term application of existing S&T knowledge and would more typically involve traditional government contractors. Code 6.6 is for RDT&E management support, and fewer details were available for Budget Activity 6.8 software and digital technology pilot programs, which was added more recently than the other codes. The DoD Financial Management Regulation, or FMR, from September 2022 refers to the RDT&E budget activities as budget activities 1 through 8 rather than 6.1 through 6.8. There is a rough mapping between these activities and technology readiness levels, and Mr. Jim Snodgrass of the U.S. Army Futures Command Combat Capabilities Development Command C5ISR Center produced a graphical mapping between RDT&E budget activity codes and TRLs. The figure shown here is adapted from his graphic and includes part of that graphic. You can look at the references shown here to learn more about RDT&E budget activity codes. Thank you for your time. If this video is helpful to you, please like the video, subscribe to the channel, and leave any comments you have for us or other viewers.